pioneering solutions, transformational technology, and inspirational leaders. I'm your host, Connor Sherman, and this is the Confident Defense Podcast. Welcome to the Confident Defense Podcast. I'm your host, Connor, and today we've got a pretty amazing guest. Our guest is Upa Campbell. She has over 20 years experience in the cybersecurity, leading across multiple areas from marketing to product management to engineering. She has served as a key executive at 4 cloud-native security startups, from RedLock to Palerra to Zscaler, and now is serving as the Chief Strategy Marketing Officer at Accurics. Upa, welcome to the show.
Thanks for having me, Connor. I'm excited about our discussion today.
Same here. Like when I first got the introduction and you and I started talking about this, I got really excited about what you and the team are doing at Accurics, because you're like, it's like we were singing off the same songbook and didn't recognize it. Because you guys are all about like, how do you bring resiliency to a cloud infrastructure? How do you bring in this concept of self-healing, which I want to dive into a little bit? How do we unlock the innovation the cloud has promised while reducing the risk along the way? Because we've had this explosion in cloud breaches at the same time that the adoption of the cloud has happened as well. So I'm really excited to dive into all of that. But first, I want to take a step back and ask, how did you get involved in the security space, especially in the cloud security space? Because you've got 4 different startups, all of them in cloud native security, all of them pushing the bleeding edge. I mean, it's most executives I get a chance to talk to have like 1 or 2 companies that they've dived really deep into this space, but you've got 4. So what brought you over to the being in the security space in the cloud native world?
Yeah, I'm happy to answer that. So, I wish I could say I had this crystal ball and I always, knew exactly where to go, but, life happens and I kind of went with the flow. I started my career as a developer, and I was recruited by a company called SonicWall, which was in the firewall space. And I was developing SSL VPN technology at that time. And, I went into product after that to kind of learn the business side of things. And then I had this itch to, find out, try the world of startups, and I didn't know where to go. So a company called Zscaler reached out to me, and I was fascinated about their different approach to securing users as people use more and more cloud. And that's where my journey started. So I started on the product side, did a bit of marketing there, and that's how I got my foray into cloud security. And then, as things happen, once you get into, into the startup world, you go from one endeavor to the next. And my next endeavor was Palerra in the CASB space, and that was, securing SaaS. And then obviously the next jump, tangential jump was to secure infrastructure, IaaS, as well as platform as a service. And so I went to RedLock. And then, here I'm at Accurics in a similar space, but taking a different approach. So I wish I could say it was all very planned, but I really enjoy technology. Must be my, developer roots. But I really enjoy, solving problems that are emerging. And that's kind of what I'm passionate about. So it kind of organically happened.
That's kind of the theme I was picking up on too. I'm like, as I've looked at these 4 companies, I'm like, when you were at each company, each one of them was really hitting that word you used, emerging solution, right? So we knew there was going to be these problem spaces, and so like Zscaler in protecting the individuals, and then the CASB protecting our data and different services, and RedLock protecting cloud infrastructure, and now Accurics, which is doing so much more. It's like if everything the enterprise is putting in the cloud, Accurics is there for that. So it's a pretty interesting flow that got you to where you are today.
Yeah, and part of it, I sometimes feel, like I've been part of the problem in creating the explosion of cloud security tools that are out there. But then, the IT infrastructure, the cloud infrastructure keeps changing, and so the game is to kind of get ahead and develop security technologies to secure the latest and the greatest. And so I feel like part of the problem, but I'm hopefully also providing some good solutions from the companies that I've been at.
I can see why you say that, but like I've had enough conversations with enough executives in the security product space where you start to really realize that while there's a lot of products, yes, there's a lot of money in the area, and like sometimes that brings some criticism. The way we actually implement innovation in security is through these products, right? As a security executive, I'm not going to go hire a team of developers to go solve a problem and that the next executive is going to do the next thing. Like why not just all go buy the same and use it? So it's just a scaling thing. And, I'm really bullish on the fact that we can have great companies solving these problems really well. And then from a consumption perspective, it's just like, okay, as a security executive, it's like identifying the right risk, identifying the right partners in technology to come solve the problem. So I'm going to take the stance that you're not part of the problem, but part of the solution.
I appreciate it.
So one of the things I want to dive into is, we've got this notion in cloud security that I think a lot of people still think that cloud security is about turning off S3 buckets to the world. I mean, we saw a lot of that, like right when people started getting to understanding AWS, and we realized, everyone having access to an S3 bucket with client data, and it's a bad thing. And we had enough of those breaches where it kind of like really scarred the environments. But like it, unfortunately, I feel like a lot of people feel locked into cloud configuration is the only vulnerability they need to worry about in the space, like turning it off an S3 bucket. But it's not what we saw with the Capital One hack. It's not what we see with some of the other things. So I was hoping you could just kind of explain what would be a better framing for understanding where we are in the cloud security space. Like what are some of the risks on the table, and what are some of the things that we should be thinking about kind of beyond just those simple use cases of, AWS benchmarks and dealing with open S3 buckets?
Yeah, absolutely. So, you hit the nail on the head there. It always seems like, oh, there was yet another company with another cloud storage service that was exposed, but really that's just a symptom of the problem. Like if we actually go back through some of these breaches and look at the sequence of events that led to a breach, the kill chain, or what we call the breach path, it's actually much more complicated than that. It's a needle in a haystack problem. But surprisingly, developers have become, or hackers have become so savvy in finding these breach paths. So, just using Capital One as an example, yes, there was an S3 bucket with, data that was unencrypted that got exposed. But really, if you kind of walk back through the breach, started with a SSR vulnerability in a compute instance that was exploited, which was tied to an overly permissive IAM role, and we hear about that all the time. And then that was associated with a database that was unencrypted and contained the data. So really, we've got to take a step back and think about, like, how do we find these breach paths, right? It's not that easy, right? If it was that easy, I'm sure people would be really locking down the environments, but it's much more complicated. And the question becomes, well, why are people missing and finding it so hard to find these breach paths and shutting them down, or fixing the misconfigurations, right, before they get exploited? And from our point of view, it's because where developers are moving so fast. So they're constantly changing configurations, and these breach paths, get created, and then instances get terminated because instances are ephemeral, right, in the cloud world. And so just staying on top of all the config changes is really hard. And just like as a security person, right, finding them and fixing them, right, fixing them is the key. At the speed of DevOps is really hard. So I think that's the key challenge, is this fundamental mismatch in development velocity versus security velocity.
That's an interesting insight. I know, I'm sure a lot of people feel that pain, but I don't know if we've actually talked about it or labeled that pain in that particular way. This the DevOps velocity versus security velocity. Because you're right, if you're trying to manually review everything and you think just having a security review of a PR before it gets released is going to be enough to keep up, well, the answer is it's not, right? So it's just not working. What are you finding that when people start to realize that they can't keep up they can't keep up manually with something that's changing programmatically? What's the switch in mindset that needs to happen for security executives so they can start to address this and start to keep pace? Not slow engineering down to, not slow DevOps down, but really speed security up.
Exactly. That's exactly right. So, you've got to combat automation with automation. So if developers are programmatically defining cloud infrastructure, then security for cloud infrastructure also has to be programmatic, and it has to integrate into the developer workflow. And I think those two things are key.
So that's really interesting. So like, talk to me about integrations. Where are you seeing success? Where are the right entry points into solving these problems?
Yeah, absolutely. So, cloud infrastructure, right, traditionally gets provisioned in runtime, and then you also have security tools that are running in runtime to detect any issues. But as developers embrace infrastructure as code technologies such as Terraform, cloud formation templates, start using Kubernetes YAML files to define infrastructure configurations, that happens during the development lifecycle. So now, all of a sudden, you've got infrastructure provision or being defined during development, whereas security tools are running in runtime. And that's again, yet another mismatch. So we hear the industry talk about let's shift security left. And so, okay, so we're starting to shift our security left, but what does that mean? A lot of people are simply trying to take runtime security tools and approaches and start using them during the development process, which doesn't work for many reasons. But one is these tools are not, they don't work with developer workflows, and they're hard for developers to use. And so we've got to rethink security, and we should start security as early as possible. And so you hear about tools that are injecting themselves in the CI/CD process and looking for security risks. Then we can actually start earlier. If developers are, writing Terraform as they're developing their application, let's start security, before the commit phase itself. So in the pre-commit phase.
That's a pretty interesting insight. This idea that like you can't just pick up the same methodology, the same tools for runtime and shift them left into the config space. Yeah, I could imagine if you're trying to take like a vulnerability assessment tool and try to say, great, we're going to pick that up, and then somehow that methodology is going to work just the same in looking at Terraform files. It tends to break. Or if it does kind of give you something, it's going to be kludgy, ugly, and friction-full.
Yep. And most importantly, the audience that has the power to fix that issue, which is the developers, right? Because they're writing the code, they don't really understand security. We don't expect them to be security experts. So for them to consume the alerts that come from these tools is sometimes a bit overwhelming. So then the question becomes, how do we make it easy for them to understand the issue being reported, and how do we help them fix it? So as you know, detection and response go hand in hand. So if we detect all these issues and we start telling our developers they have all these problems, it's going to frustrate them. So not only should we detect issues during the development phase, we should also provide a way for them to be able to fix them quickly, right?
What a revolutionary concept. Provide a solution, not just a list of problems.
Yep. Yep.
I had a guest on the podcast not too long ago, and this was one of the great insights he put in. Is was like, in incident responder, when you have a breach event, an incident responder is powerful. At that point, when they say we need to do X, Y, and Z, you're just saying yes. It's like stop the bleeding, get the adversary out, get out. They have pretty much autonomy to do what they need to do to fix the problem at hand. But the security engineers pre-breach who are trying to integrate and solve these problems and do risk reduction ahead of time are powerless. They have less power there. And they're often shuffled into these little processes with lots of change control and 4-week lag times and this kludgy thing, because we're trying to reduce the risk of change that comes in from the security engineer. When that same person is trying to reduce the overall risk at all. So there's like this at odds moment there, but they are powerless in that space. So, and what we kind of came to the conclusion was, and this is what you think you're saying here, is to change that dynamic, to take someone who's pre-breach, a security engineer, and equip them and make them powerful, they need to arrive to the table with a solution, not just a list of problems where there's like a negotiation and horse trading on who's going to fix what.
That's exactly right. Yeah.
So where are you seeing organizations win at this? Like, how do we do this? How do we actually approach, take that idea I just said and start to implement it and start showing up with these solutions versus just lists of problems?
Yeah, absolutely. So yeah, let's talk about what does programmatic security look like starting, in the development lifecycle. So as developers write their infrastructure as code, we've got to start with programmatic detection. And what does that look like? Well, there's two ways to do programmatic detection. One is what we call policy as code, and the other one is what we call security as code. So let's start with policy as code. Policy as code is basically, defining policies that you want to check your infrastructure as code against, and either pass or failing based on these policy checks. And there is the OPA project from the CNCF, from the Cloud Native Computing Foundation, or OPA, which is a de facto standard for policy assessment. So you could potentially, write your own policies, or there are tools that have predefined policies that you can use to basically, as soon as developers write their infrastructure as code, it's constantly checking, saying, are there any misconfigurations that violate these policies? And if so, let's notify the developers so they can fix it for the detection portion. And I'll give you an example of a really good example of where policy as code can be powerful. So I'm sure you've been following the news. There was a lot of discussion about this man-in-the-middle attack, Kubernetes vulnerability that was disclosed in December. And at a very high level, basically there is no patch for this vulnerability today. And the way this vulnerability can be exploited is there's a couple of services within Kubernetes, so cluster IP and load balancer, which are vulnerable to the attack. So effectively, an attacker can create a cluster IP service and set what we call this external IP field to basically route traffic destined for that IP address through the service. So effectively, they can intercept any traffic coming into the Kubernetes cluster. And so the way to basically prevent this exploit, so like get ahead and reduce this risk, is to ensure that no cluster IP service is allowed to be created that contains an external IP spec, right? And that's a policy-based check. So at Accurics, we have an open source tool called TerraScan, which we wrote a policy for really quickly and rolled it out, where basically if you run TerraScan to check your infrastructure as code as you're writing it, we can check to see if this configuration is being allowed, and if so, we can alert your developer saying this is a high-risk violation. So that's where policy as code can be really powerful. So that's one method of detection.
And I wanted to pause there for a second, because I think there's a lot in that story, right? Mm-hmm. Where, like, from my understanding is of that vulnerability, like, this is particularly acute for organizations that are running in shared services. And like, so if you're using AWS EKS or any of the other shared Kubernetes, managed Kubernetes environments and such. And it's one of those things where, like, if you get it wrong, if the adversary is able to exploit this, they really have a huge foothold into everything that's routing through traffic. And especially if you're an organization that still hasn't moved into TLS for service-to-service communication. So now you have like unencrypted traffic running through a load balancer. The adversary sees a copy of it, and we're talking everything goes through there. And it's almost like we reround the clock to 1990s network security with someone with a tap in the middle, and they're just saying, let's see those credentials, let's see that data go over the wire as it's going. So it is one of those things where it's, by misusing Kubernetes the way it's designed, mm-hmm. but in a novel and malicious use case, the adversary really is able to see so much in there. So, but to your point, but the solution is really simple. Don't allow public IP addresses to be associated with your load balancers, and this will stop the traffic routing externally. And then, boom, okay, now we've got the container back around our environment again.
It's just a policy-based check early in the development lifecycle. Like, you never have to let this get to runtime, right? And so policy as code is fantastic for just detecting these issues early on.
And so would it be a fair way of saying that, like, policy as code should be viewed more as like a hygiene check, or it's more of just, this is the standard of how we operate, and you have to be this high to ride the Ferris wheel. So, you can't go into production unless your environment doesn't violate these safeguards, these boundaries that we put in place.
Yeah, exactly. So policy as code is just a great way of ensuring hygiene of your code before you get to production or runtime, and just ensures that your cloud infrastructure is born secure, right? And that'll just greatly reduce your attack surface from the get-go. So why not?
I'm going to steal that phrase, born secure. I like that a lot. Okay, cool. So you mentioned that was one of the ways that we can leverage detection. Detections code. So what was the next one you're referring to?
Yeah, so policy as code, as you correctly point out, is great for just establishing hygiene. But then in an environment where you're moving really fast and there's a high development velocity, you can generate a lot of noise with policy as code. So then the question becomes, hey Connor, you told me I have 100 violations. Which one do I fix first, right? How do I prioritize and know which one's really a risky? Because not all risks are equal, right? Mm-hmm. So from that perspective, we believe in this notion of security as code, which is using not just policy-based checks, but threat modeling. And what we do there is we basically create a topology of your infrastructure based on reading your infrastructure as code. Then we basically build a threat model using frameworks such as like the MITRE ATT&CK framework and CAPIC. And then we pinpoint in that topology saying, here's where all your threats are. And then the next step is to say, okay, now that we know your threats are, is there an actual breach path that we can see through your environment? And if so, this is the risk you should probably fix first amongst the 100 that we reported, because this is where you're most vulnerable today. And so in addition to policy as code, there's got to be some level of threat modeling and intelligence to help developers prioritize which risks.
If I could achieve one New Year's resolution, it would be that every organization has the time, understanding, and capability to do threat modeling on their critical assets. It's just like, it's one of those things where, well, if your risk is based on trying to hit a compliance, you're a different space. If your risk you're trying to go for is risk reduction is around preventing the adversary from getting in, then threat modeling, you got to do it. It just has got to be there. And it's hard, right? There's a lot of moving pieces to get that right. So if you're trying to do it manually on a whiteboard, or even a Zoom whiteboard, it gets really difficult to do that. So programmatically seems to be the only fighting chance that we have as practitioners to doing this consistently.
Yeah, exactly. We spoke earlier about the mismatch in velocity. I mean, you can have these breach paths being created left, right, and center, and there's just no way to humanly keep up. And so if we don't rely on threat modeling to help us identify these quickly and fix them quickly, there's just no way we can keep up with the velocity that developers are moving at.
And I think I go back to that the vulnerability that we see in Kubernetes, right? One day it's not there. We're not thinking about it. We don't know about it. New day we have a vulnerability. This changes our entire landscape across everything in our cloud infrastructure instantly because we've got a new novel way of doing this. So the idea of like going back to the beginning and redoing all of your threat modeling and all of those breach paths again over and over every time a new vulnerability, a new weakness is discovered. Again, that's a velocity mismatch again.
Yeah, that's a great point. Exactly right. I mean, things are changing so fast in the threat landscape. It's hard to keep up.
So once we've kind of gotten this idea that we can have boundaries and safeguards and with the policy as code, and then we're doing the securities code, we've got the breach paths coming in. We understand, okay, this is the actual priority because we can predict with confidence the adversary could exploit 1, 2, 3 and get where they need to go. Where do we move next in the maturity landscape?
It's so we talked about programmatic detection. Now you've got to get to programmatic response, or what we call remediation as code. So, there's different ways to do response, but ideally you want to design a method that fits into your developers' workflows, because at the end of the day, they're the people that are going to be making these fixes. So one potential approach to remediation as code is to create these pull requests. And by that, I don't just mean create a pull request with, recommendation how to fix it. I'm saying that programmatically generate the correct configurations, and then send it as a pull request to developer, and have them review it. And if they have no concerns about the proposed change, have them merge it into their branch. And it's that simple. So what you're doing there is you're empowering your developers to make these decisions without being security experts. So you're guiding them and you're helping them do this at speed, right? Because all they have to do is review and merge and they're done. So that's what we believe is required to do programmatic response.
I don't know if there are any statistics out there on how like happy developers and engineers become when they are given a solution versus a problem, but I can only imagine the friction that reduces when you can literally just say, here is your 80, 90% of the way there. Let's just make sure it's got our global variables in place and off you go. That's pretty incredible that you're able to do that. So how are you guys doing that? Like what's driving that? Is it just this kind of like continual assessment of what your Terraform looks like? And so when we recognize you're in this risk state, you can then present the Terraform that would correct it back in?
Yeah, that's exactly right. So we're reading your infrastructure's code. So it could be Terraform or Kubernetes YAML files. As soon as, there's a commit and somebody makes a configuration mistake that we think is a risk, we will actually automatically generate an issue. So you know that there's an issue there. And then we also create the pull request saying, here's how you fix that configuration, and we'll attach it, we'll submit that to them, right? And we'll notify them Jira or Slack. So we're basically working with a developer to help them fix these issues. And from a security standpoint, you've got your day job, right? Just chasing after each violation is not is just not a good use of your time. And so it really is a win-win for both sides, right? Developers are fixing their own issues, and security team can focus on more strategic initiatives.
Yeah, like preparing for a breach with tabletop exercises or whatever the case may be.
Yes.
All the while we're giving it seems like a really powerful Archimedes lever to be able to work with developers inside and SRE teams inside their pipelines, presenting them solutions, getting them there. I mean, talk about reducing friction. I know I say that over and over again, but like, I'm just like on this warpath for like, how do we as a security community really bring enablement and empowerment to the teams that we work with? The era of the CISO who says no is gone, right? It's all about how do we go faster and safer. Anyway, that's my next tattoo. Faster and safer.
Right. Yeah. Right. Actually,
Okay.
I did want to interject with one little, other idea. So in addition to obviously scanning infrastructure as code as developers writing it, then you get to the next phase of CI/CD. Security teams should have an ability to basically say, hey, look, developers, we're on the same team, we're working together. I'm going to empower you to make these decisions for remediation. But at the end of the day, there's a few things I'm going to have zero tolerance for. So I never want you to be able to, create S3 buckets exposed to the public or SSH ports open to the internet, because that is just a heinous risk, right? Making that up. But what should be allowed to happen at this point is there should be a way for security teams to say, for that policy or those two policies, no matter what our developers configure their S3 buckets, we will always override it and make sure that it is never publicly exposed, always private. Or we will always make sure your SSH ports are not open to the internet. And you should be able to override these insecure configurations with secure configurations during the CI/CD process, so that again, when your infrastructure is provisioned, it is always provisioned with secure config, right? And so that's what we call self-healing, where on a per policy basis, security teams can then make sure those very dangerous risks are never make it to runtime.
I love that idea of self-healing. I know you guys lean into that a lot at Accurics, but this idea that you could say, this is the place, this is our risk tolerance. And we can actually mean that phrase when we talk about it. For 15 years, we've talked about risk tolerance, and we're outside or inside, and it's all been inside a spreadsheet. It's all been inside a game and a conversation that we've had to play of maybe this, maybe that, and quantifying risk tolerance. But here we can just literally say, this is not allowed to exist in our environment, or it's default no, and then you add in this bucket is permitted via human review, and that's allowed to go public, whatever the case may be. And so that idea of programmatically putting in safeguards, so we can say that's not allowed. And these ones, we don't have as firm of standards around because of the context that's required. So therefore, we move into an alert phase and let a human make a decision on where we are there.
Yeah, you got it.
Yeah, I think this is probably the only way for security leaders to have a productive dialogue with the heads of engineering and SRE teams.
Yeah, absolutely. We completely agree with that.
Now, I'm intrigued though. So we get to security as code. You mentioned there was another one after that.
Oh, so yeah, the two ways of programmatic detection are policy as code and security as code, and then we pair that with remediation as code for response. And this is just to secure your infrastructure as code before you get to runtime. And then there's the whole runtime side of things. What do you do in runtime, right?
Interesting. Let's unpack that, because I do want to talk about runtime for a little bit, because I think there's what you've explained here is, I think a lot of the world right now in cloud security is focused on runtime. Like, what does my production look like? Do I have someone with a C2 channel going back home to the malicious toolkit? Do I have A, B, C, and D happening? So what are some of the areas that people should be looking into and paying attention to inside of runtime? How do we shore that up more effectively?
Yeah. So from the point of view of cloud, infrastructure configurations, right? What we've talked about so far is let's make sure our infrastructure is configured correctly during the development process, and then let's run the infrastructure. Now the reality is, in a perfect world, that infrastructure configuration would not change in runtime, but that's not reality, right? For, as we know, SREs will come in and they will change configurations in runtime. So there's always break glass scenarios that will happen. And that's okay, because sometimes you do have emergency situations where you need to make a change during runtime and it's too expensive to go back change the config in IAC and redeploy another build. It just doesn't happen, right? And so we recognize that changes. So even though you've done your best to really lock down your IAC, someone is going to change that config in runtime. Now, sometimes that change in runtime could be non-risky. So they might change like a memory config of a compute instance, or sometimes they may open an S3 bucket to the world, right? And so we've got to think about how do we want to handle both scenarios. So starting with a scenario of, it was a non-risky change, SRE came in, they updated the configuration, memory configuration of a compute instance. In that case, let's assess the risk and make sure that it doesn't introduce risks. So obviously in this case, it didn't. But the problem is we've updated the memory config in runtime, but nobody went and updated the infrastructure as code config for that memory. And so if somebody redeploys a build using the IAC as it stands, from the original config, that change in memory config will be lost. And so that is actually, forget being a security problem, that's fundamentally a big problem from the point of view of drift, operational drift. And so now you have this infrastructure as code, which is supposed to be your source of truth, yet people are making changes to your config in runtime and they become out of sync. So your code and your cloud are no longer in sync. So how do we solve that? So this whole notion of drift is becoming a major problem as organizations move to IAC. So that's something we have to solve for. And then there's the whole aspect of non-risky change, a change that does introduce risk, which we can talk about as well. But that's what we're seeing, and I don't know what you think about that.
No, I will definitely come back to the risk portion of this, but as you're having that conversation, as you were just saying that, I was thinking like, okay, well, this from like a BCP DR scenario, right? Where we've got business continuity issues, or where like, so if your production does drift from your code base, then if you're not actively reconciling the two, the only time you're going to reconcile is when you have a problem and you rip something out of production and you push back in from the code base, which is generally during an emergency or during some large change. And then you've got multiple changes that broke at the same time. And then, of course, my years in operations come back and I have PTSD and we have to have that conversation later. But it's like, you have all that anxiety that comes back when you start to have this drift over time. So it is pretty like just like a pure, like you said, just get rid of security for a second. Like, does what you think running in production is running in production? Just solving that problem alone is worth everyone's attention, paying attention. It's worth everyone's mental space to pay attention to, in my opinion, because it's just the amount of business operational risk it introduces.
Yeah, exactly. That's right. Business continuity risk. That's exactly it. But the good news is, you can use exactly the same methods of programmatic detection and programmatic response that you had during the runtime phase as well. So you could have use the same policies that you were using to check your IAC to check and continuously monitor your runtime configurations and assess them for policy-based violations, right? You can also use security as code to detect risk. So again, if somebody changed a config in runtime, you want to, quickly or programmatically rebuild your threat model and determine, did this config change in runtime introduce risk, right? So that programmatic detection that you have built or are using for your development phase should also be the same, models that you're using in runtime as well to detect risk. And once you've detected risk, same programmatic response mechanism can be used. So let's say in this example of this non-risky change we made, it would be very easy to then say, okay, this change is non-risky. Let me generate some code which updates the memory config, and then let me send that as a pull request back to the developer saying, hey, somebody changed your config for your compute instance in runtime. Please update your IAC so that you stay in sync with runtime. And again, your pull request-based remediation as code method can be used to remedy this drift, right?
Again, what a novel concept. Security bringing solutions to the table for somebody else's team.
There you go.
I love it. I love it. Yeah. And again, you start to talk about like, now this is a great way of like solving for persistence in the environment, solving for an exploitation. Like we didn't build an environment that was compromised. If it's now compromised, there was change introduced. What was that change? So I imagine getting a root cause would be much quicker as well. If you can come back and say, whoa, that came out of sync. Did you actually want that to come out of sync? This looks risky. And then of course, they may know exactly where the problem is because we've just deduped the I imagine we've just deduped the change in the environment.
That's right. Yep, exactly.
So where are organizations finding the greatest value when they start to adopt this methodology? Is it there's just so much value along the entire chain? It's a little hard to say. Are people finding, okay, really it is this ability to give tool sets back to the engineers and working inside their environment? Like when it comes to an empowering, enabling story and how what you guys are seeing with a view that you have in the environment, where are you seeing security leaders really diving into around this platform?
Yeah, so I think there's a lot of benefits for the security team because doing the first part, which is securing your infrastructure as code, is hugely beneficial because you're basically, ensuring hygiene and reducing your attack surface from the get-go, right?
Mhm.
Which is just a huge plus. So I see a lot of security leaders really like the idea of implementing, programmatic security during the development phase. Um, and then as you get to runtime, implementing those exact same policies and not having to rewrite all your policies for runtime is again another benefit, right? You're leveraging what you've already done during development in runtime and running the same checks and threat modeling during runtime. And so it's really important. Economies of scale, right?
Right.
And then lastly, just making sure you are taking these alerts and sending the fix or the remediation as code to developer really takes the heavy lift of all this alert fatigue off the security team, right? So they're really working closely together with developers and really allowing them to focus on other things, right? And so that's where I feel like there's at least 3 or 4 benefits that they have that they're seeing with this approach.
Got it. I love it. Again, empower, enable, put working in the same tools that everyone's normally working in. It's pretty impressive stuff. Now, you guys are part of the CNCF, if I understand correctly, right? So the Cloud Native Compute Foundation, which may be one of the greatest things that we've ever put together in the last decade, is the CNCF. Big fan. The fact you're able to leverage projects from them, such as OPA, the Open Policy Agent, for that policy definition. But what I also like is the other side of this coin, where you guys are giving back to the community and you're really allowing people to understand what their risk posture looks like inside of Terraform today. So I got very excited when you told me that you had this open source project called TerraScan. I was hoping you just take a moment and kind of break it down. What is TerraScan? What is some of the value it brings to organizations? And if people wanted to dive in, how would they get their hands on that code?
Yeah, absolutely. So Terrascan is an open source offering that is maintained by Accurics. So if you go to github.com/Accurics/Terrascan, you can get the tool over there. Simply download it and run. There's instructions on how to run it, but basically it allows developers to constantly check their infrastructure as code for policy-based violations. So of the 4 pillars we talked about earlier, you can do this policy-based checks during development using TerraScan. You can also implement TerraScan in CI/CD pipelines. So you're checking, you're basically part of the developer workflow. So if nothing else, it allows you to establish that baseline of knowledge of what you've misconfigured, right?
Yeah, and really just illuminate kind of what is the state of affairs, right? A great example someone once gave me was he was trying to bring an analogy to understanding just AWS infrastructure, and this could be applied to any of the cloud providers. He says, it's not like trying to learn, it's not the difference between driving a car, which one is a manual car and one's an automatic car. It's the difference between driving a car and operating a battleship. It's like there is such complexity when it comes to trying to operate an AWS environment or any of these cloud providers that you do need that kind of programmatic view of the world where there is technology helping you. And as you said, fighting automation with automation, leveraging automation to solve problems that were also generated through other automated tool sets. So I think just a bit of praise. I think it's pretty fantastic. You guys have this actively maintained project that you're giving back to the community.
Yeah, we're very passionate about the community and really, committed to help them, have tools at their fingertips that they can download and just use as they're developing their code. Because, if we can get developers adopting this kind of technology, I think it's a win-win for all of us.
Absolutely. Well, Appa, thank you so much for your time today. I mean, we've talked a lot about here about how to really get our hands around cloud security. There's so much more I want to dive into. So I think maybe a part two will be coming in the coming weeks and months here. But I just want to thank you so much for joining us on the show and really bringing the expertise that you've developed over 20 years of being executive in these security companies and laying this out for us.
Oh, my pleasure. Thank you for having me. I really had fun, and I'm happy to be back for a second session.
Appa, thank you again. Enjoy the rest of your day.
Thank you. You too.